All right, everybody, and thanks for tuning in to the Daily Space Weather Show. We've got some exciting stuff going on. It's a banner moment for space weather. There's a major geomagnetic storm on the way. A little bit of disparity in the forecasts. We'll talk about it. You may also see a filament release happening down there in the southwestern limb. That's the Eugene Bagashov filament. We'll talk about that and show you some spectacular footage. We'll also talk about lots more of what's going on all the way from space weather down to your Earth weather. These are 24-hour videos from SDO, and we do have a significant number of filaments on the Earth-facing portion of the solar disk. There's one up at the North Polar region. And here's the newest large sunspot. It's beta gamma class, and it does increase the probability of large solar flares around the eastern limb. There's also a new sunspot that just rose down there in the southeastern limb. This imagery is great at showing the lower corona, that's the 171 angstroms portion, as well as the extended corona, active regions and filaments, that's the 211 angstroms wavelength. Both are ionized iron. We've also got setting sunspots and magnetically complex sunspot groups in the northwestern limb. So there is a significant possibility of solar flares on various portions of the Earth-facing solar disk. Some fine imagery from the Solar Dynamics Observatory. And let's take a look at that southwestern limb, as that filament is in the process of ejecting, perhaps even reorienting. It looks like a large portion of that is about to eject. Here's a little closer view of that. These have been all 24-hour videos. How you like them apples? Pretty sweet, right? All right, so let's take a look at sunspots here just for a brief moment. Here's the SDO continuum yesterday plus today. You can see degradation of this sunspot, although, oh, check it out, a new group formed to its north. So we'll have at least 3 new sunspots there in the past 48 hours. This one in the northeast, this one in the southeast, and another new sunspot group there just forming rather rapidly in the northwest. So it's already beta gamma class. Here are the magnetic fields. You see that right in here, right there. New sunspot forming. And before we take a look at what's going on planet Earth, we need your help to keep this channel in existence. So please visit our links. Some of the links that you can find would be the links to smashomash.com. We launched a massive web ring in February of 2019 because a crack YouTube unit was sent to social media prison for a crime we didn't commit. We promptly escaped a maximum security social media stockade of the internet underground where we survive as producers of fortune. If you have a problem, if no one else can help, and if you can find the content, maybe you can hire the Smash team. So visit us on social media and press that share button. Do yourself a favor if you're new to the channel and press that subscribe button, because, well, where else are you going to find the world's most comprehensive daily space weather and most detailed solar imagery? There is nowhere else to find it. So press subscribe, press like, press the share button. If you're an influencer, drop us a line. We'd be more than happy to appear on your channel. So hit us up. Welcome to the Neo-Renaissance. And again, we need your help to get these videos onto screens. Give Smash staff and I a raise by visiting our links, hitting up some merch. We'll talk about the merch a little bit later, and let's take a look at what's going on planet Earth here. We've got a little bit of a volcanic downtick since yesterday. Yesterday we reported on Shishaldin in the Aleutian Islands producing a 42,000-foot ash plume. Today it's a bit of a a lull in volcanic activity compared to yesterday. So Mount Mayon is still erupting, producing a 9,000-foot ash plume over the Philippines. Popocatépetl producing a 21,000-foot ash plume there over central Mexico as it explodes to flight level 210. San Chiquito exploding, flight level 150. That's in Guatemala. Also Fuego in that same country, also exploding, flight level 160. Sangay in Ecuador exploding, flight level 190. Revenador in that same country exploding, flight level 150, and continuous ash emissions from Sabancaya are a reminder to not pole vault the caldera, but do visit our links, which you can find in the description. Next, earthquakes over the past 24 hours, and there's certainly one noteworthy one. Keep in mind, folks, any earthquake can be a foreshock. So just recently, in the past about hour, from producing this video, there was a 5.6 in the Cascadia fault zone here. In the Pacific Ocean there, near Queen Charlotte Sound off the coast of Vancouver. So again, any earthquake can be a foreshock. That 5.6 occurred at 11:28 Universal Time this morning. We'll call out the rest of the quakes in the past 24 hours that are of 5 or greater magnitude. So there's a 5.1 on the mid-Indian Ridge there, right in the middle of the Indian Ocean. That 5.1 was at 13:47 Universal Time yesterday. South Sandwich Islands had a 5.0 at 17:31 yesterday afternoon. There's that 5.0. Indonesia had a 5.0 at 21:17 yesterday evening. That's yesterday, September 16th. Chile had a 5.0. That was at 2:18 Universal Time this morning. And then another one. That one at greater depth. And about 2 hours later, another 5.0 there, farther north. So 2 Chilean quakes there of a 5 magnitude. And again, that 5.6 occurring near Port McNeill, Canada. 5.6 magnitude quake there. The largest we've seen in that area for quite a long time. And last but not least, at 11:54, right when we started producing this video, Solomon Islands had a 5.0. So that's the earthquake situation. And let's take a look at some more imagery here of the closest star. Again, we've got this spectacular filamentary eruption down here in the southwestern limb. It's the Eugene Bagashov filament. So great thing about naming filaments is if they do become solar storms, then you can name the solar storm after the person as well. The one that's going to strike late on the 19th to early on the 20th will be the Tamitha Skov solar storm. And we're expecting a major one. Possibility of a KP8. Let's briefly take a look in 304 angstroms here. These are more 24-hour videos. Ionized helium here shows great depth. 2 solar filaments, also active regions, show up well in 304 angstroms. We did name 2 more filaments around the eastern limb after Tim Dunkerton and Reed Timmer. Here's the equatorial view. And actually, the Tim Dunkerton filament has partially collapsed and partially ejected. It's right to the left of the Earth scale there. It went straight from being a prominence to being a coronal mass ejection, a minor one, and it's not earthly directed. That's 24 hours of the equatorial view. And once again, we'll look at the southern hemisphere. And let's briefly fixate on that southwestern limb. When we say we provide the most detailed solar imagery in the known universe, we're not kidding. So that's where space weather originates, at the source, the closest star, El Sol, aka Helios. And let's take a look at some more stats here. The 10.7 centimeter radio flux, now at 140 solar flux units. If you're wondering what that is, it's a radio signal that comes out of the upper chromosphere and lower corona, right about where my pointer is. That's where the radio flux comes from, and it's directly proportional to the sunspot number, as you can see on this 1-year chart. The black line is the radio flux, the red line is the sunspot number. And seeing another little lull in activity here. And let's talk about the space weather enthusiast dashboard. So now NOAA is expecting this geomagnetic storm to show up a little bit earlier than we thought. So NOAA looks like they're expecting it to be moving a little bit faster than we thought. We thought it would show up late in the day on the 19th. NOAA's calling for it early in the day on the 19th, which is actually perfect for our video content because, well, we'll be producing a video around that after that time, actually. So if we are in major geomagnetic storm conditions, and again, we could get as high as a KP8. NOAA's only forecasting to a KP6. We could see quite higher conditions than that. So that's the situation according to the Space Weather Enthusiast dashboard. That is NOAA's forecast. And let's take a look at NOAA's Enlil spiral. So there's NOAA's Enlil spiral. And again, you can see expecting it to show up early in the day on tomorrow the 19th. I believe Tamitha Skov and I both agree that we're expecting it to show up a little bit later than that, but anyway, that's NOAA's forecast. Also, NOAA's expecting it to not be quite as earthly directed, and there are some issues with, I think, the modeling of that plasma, but we need more people studying space weather, not less. So I welcome any disparities in the forecast. I'm sure they have their reasons for modeling it the way they did. That's NOAA's Enlil spiral, and here's NASA's Enlil spiral. Now NASA has it missing more to the west, which I believe is correct, but they also don't really show the if you look at this panel right here, the middle panel, it's actually showing it more directly toward Earth than Tamitha Skov and I seem to think. We seem to think the densest core would be off to the south a little bit. So I think, and so does Dr. Skov, that the densest portion is going to be down here, not right on the Earth line. So anyway, it'll be yet to be seen. It should be interesting stuff on Tuesday the 19th into Wednesday, perhaps, and kind of expecting it to be a long duration CME impact. Anyway, that's NASA's forecast. So continuing on, let's take a look at Earth's magnetic moment from space. We are in a geomagnetic unrest condition here at the moment. That's the past 4 hours of magnetohydrodynamic pressure. Geomagnetic unrest, because the CME that was a more minor CME arrived right when we forecasted it early in the day today on September 17th. It's not going to be noteworthy compared to the Tamitha Skov filament impact, which will likely become the Tamitha Skov geomagnetic storm. The last time we named one after Tamitha Skov, it actually turned out to be a KP 7.67, so nearly a KP 8, once again as forecast. So here's Earth's magnetic moment from the ground, and we did see some auroral imagery being shared on Twitter. Make sure you follow us over there. Thanks to our new Twitter followers. That's the past 4 hours of Earth's magnetic moment from the ground over North America, and certainly Canada did indeed see some aurora. So here we'll show the global view, which we show daily on the channel. That's the past 4 hours of Earth's magnetic moment from the ground, showing the likely places to see both the aurora borealis and the aurora australis, as winter is about to come to an end in a spectacular fashion for the southern hemisphere, as summer comes to an end in a spectacular fashion in the north. So that's the last 4 hours of Earth's magnetic moment from the ground. This depicts magnetic flux density, the units of which are nanotesla. And things are subsiding here in the past couple of hours. Next, we're just going to show the geoelectric field map, and this is because, well, this is a great way to figure out where the aurora might be visible over North America. So we highlighted this yesterday. I just wanted to show it. As you can see, some induced voltage there in the electrical grid system. And you can expect this to light up pretty hard, possibly on the 19th and 20th. KP index currently at Well, 3.33. It's just this side of geomagnetic storm conditions, geomagnetic unrest. It's calm, but barely calm. So let's take a look at the solar wind next. So here's the CME impact. And again, it was pretty minor. So we only saw the density get to about 16 protons per cubic centimeter, maybe 17. Speed was nominal here at about 500 kilometers per second, but only for a brief period there. The magnetic field shifted, also the plasma temperature shifted, so that CME was a little bit hotter than the background solar wind. Current conditions are just over 450 kilometers per second for the solar wind speed, solar wind density there, a little over 8.5 protons per cubic centimeter. GOES magnetometer showing some spiky readings there as we forecasted. Again, it's been a minor coronal mass ejection impact. Expect that to be a lot more jiggy on the 19th and 20th. That's the GOES magnetometers, the GOES 16 and GOES 18's magnetometers for the past 3 days. Next, our top view ecliptic plane field plot. And there has been some heliospheric current sheet polarity sector boundary crossings happening here. If you look at the latest image, there is a North Pole current sheet not too far away. There's the North Pole current sheet. Earth is currently in a South Pole current sheet. And yeah, it's a couple days out here. The South Pole current sheet may actually extend. You can see some evidence of that in the last image. So the South Pole current sheet may be here for a couple of days yet. It does depend on the evolution of those new sunspots on the eastern limb. Next, our line of sight field plot. This depicts solar polar fields in green for north and red for south. The solar B field, which is sort of like a net field. It's the field that goes through the magnet, this magnet being the sun. And then, of course, you've got the grayscale gong magnetogram, which brings us to coronal holes. So coronal holes are super important as they show us the solar polar field reversal process during a solar cycle. And we've got mostly south pole coronal holes here on the center of the solar disk. We do have some North Pole coronal holes down here in the south and some rising up in the east. So that's the current situation. And let's take a look at coronal holes from the perspective of SDO. So there's 211 angstroms. These are South Pole, and these are North Pole coronal holes. So that's another 24-hour video from Solar Dynamics Observatory. Coronal holes, super important to the solar cycle progression. And we can expect a big uptick in coronal holes in the coming years because, frankly, throughout this cycle, we have seen a coronal hole shortage. Next, sunspots. And we do have a few groups that could produce large flares. So mainly the northwestern limb, so this area up here, and then, of course, sunspot 3435 also has some capability to produce large solar flares. So that's what's going on with sunspots. Again, we'll have at least two new named groups today. This new group right here, and this new group that rose in the southeast. So those will be 3436 and 3437. And here come some views of sunspots. So first, the SDO HMI magnetogram. And you can see that sunspot forming right up here. There's that sunspot forming. And then you'll see this group rising in the southeast. Here's the HMI continuum from Solar Dynamics Observatory. And that new sunspot in the northwest did form quite rapidly. It is already beta gamma class. We will show some more detailed analysis of its magnetic field structure right before we switch to meteorology. And the next thing to cover is energetic particles and solar flares. So we did have a minor solar energetic particle event here. You can see a little spike in the proton flux there. It has since subsided. That's a 3-day proton flux measurement by the GOES 16, measuring 3 different energy levels, greater than or equal to 10 mega electron volt, 50 mega electron volt, and 100 mega electron volt. The spike was only in the greater than or equal to 10 mega electron volt range, which is represented by the red line. Solar flaring has been minor. It's been subsiding over the past 24 hours. It is still right around a C1 class level of background flux. Make it a B 9.6. So a little bit of a downtick there in the X-ray flux, generally speaking. And let's take a look at some flare wavelengths. There is 94 angstroms, a 24-hour video from SDO. And again, there are multiple locations where we could see large flares. Mainly M-class flares are currently likely. And let's show the other wavelength that takes 10 images per minute, 131 angstroms. And now, to be complete with our space weather forecasting, let's talk about what's going on overhead. This star chart is from skyandtelescope.org, and Mars and the Moon are both just peeking up over the horizon there, chasing the sun across the ecliptic. That's what's going on in Lehigh Valley, Pennsylvania. If you want to make your own star chart, head to, again, skyandtelescope.org. Just put in your zip code, your city, whatever. If you're viewing the pre-dawn sky, you might be able to see Venus. That's quite likely, as it is the 3rd brightest object in the sky. Also, if you've got low light pollution and a low horizon and no clouds, you might be able to see Mercury, Jupiter setting there on the western portion of the ecliptic. Next, your solar system forecast. Here's where things are today. We'll advance this 1 week. Here's where things will be on the 24th of September. Just a couple days into autumn there for the northern hemisphere. And let's take a look at the astronomy photo of the day. Yeah, the astronomy photo of the day. Check it out. That is an annular eclipse. And what you're seeing there is the moon's mountains reflected in the coronal halo there. So those are actually lunar mountains there shown in reverse relief. That's the astronomy photo of the day. That's annular eclipses are caused by the moon being kind of far from the Earth. So annular eclipses are when the moon doesn't completely cover the solar disk. You get this ring of fire sort of feature. And in this case, those great images there showing the lunar mountains. apod.nasa.gov if you want to view that yourself. apod.nasa.gov. Next, coronal mass ejections. So here you'll see this Tamitha-Skov filament blasting off there. And you can see that dense core that we were talking about earlier. The densest portion of it clearly is to the south. Not sure how anybody missed that one. It's super obvious in the imagery there. So that's yesterday's 100 frames of coronagraph imagery from George Mason University. Difference imagery on the left, and the Soho-Lasco C2 raw coronagraph on the right. There's that nearly full halo CME, coronal mass ejection, slated to arrive sometime on the 19th, and perhaps even lasting into the 20th. So here are some additional frames from today. You're going to see a little bit of an outflow on the eastern limb. That's the Tim Dunkerton prominence, having part of that ejected. I think part of it's also collapsed there. So that filament could rise again here shortly in the eastern limb. That's only 19 frames from today, so let's skip ahead here and look at the Soho-Lasco C2 and C3. C3 is just a further zoom out. And there's that massive CME. that's likely to cause a significant geomagnetic storm. Here you can see the tail end of it once again. There it is popping off on the C3 on the right side. Since then, things have been pretty calm. Let's take a look at stereo A as well. We'd like to show this image because it shows you where stereo A is located. It's recently passed Earth. So that's where it is, that red circle there. That is stereo A's location. It is gaining on the Earth there, orbiting a little bit faster than the Earth, and giving us a little bit better view of what's going on. Here's the difference imagery from stereo A on the right and the raw stereo A coronagraph on the left. Again, no major stuff going on since yesterday. A little bit of a respite there. So let's switch to our custom views. We've got some spectacular ones, as you may have come to expect from the channel. There's a 24-hour video with LASCO C2 and C3, as well as 193 angstroms from the Solar Dynamics Observatory. Starting out with the tail end of that Earth-directed coronal mass ejection. And then calming down. Here's a little closer view. These are all 24-hour videos, by the way. It makes it easy for us to do daily space weather. We used mostly 24-hour videos. Of course, it does vary based on what time we decide to make the content. One day, perhaps, we will have a set time to put out these videos. That is one of our future plans, we're hoping. So it all depends on you pressing the like button. Make sure you press the like button, folks. It's very crucial. The algorithm cares if you press like. So there's 193 angstroms by itself. Again, forecasting a major uptick in coronal holes in the coming days and in the coming couple of years, for that matter. And let's take a look at filaments, since there are still some major ones. And we do have filaments named here. So let's talk about the names of these filaments. We've got, this is the Scott McIntosh filament up here in the northwest. Down here in the southwest, we've got the Eugene Bagashev filament. That is in the process of ejecting right now. And then we've got this one over here. That's the Tim Dunkerton prominence. And then you've got the Reed-Timmer filament up here. So that's the filament situation from the El Teide, Spain Hydrogen Alpha telescope. We'll also show grayscale since it does show prominences. There you can see that Bagashev filament there making its way out. And it looks like it is partially ejecting and partially repositioning itself. So Eugene Bagashev filament there, making sure it stays in the limelight. And by the way, make sure you subscribe to Eugene's channel on YouTube. It is Eugene the Philosopher. Let's get him to 1,000 subscribers so he can monetize. And then be astounded how nobody sees his content. Yeah, so there's the past 24 hours we've put together. We've added 304 angstroms here to the 193 angstroms wavelength because it shows such great definition to solar plasma filaments. There you go. Another 24-hour video for you. And we'd invite you to name filaments, but we pretty much have them all named. Thanks to our new Twitter followers, by the way. Make sure you follow us over there. If you're on social media, follow us on Twitter. If you've unplugged entirely, hey, we don't blame you. It's the state of censorship is quite pathetic. Quite pathetic indeed. Free speech. The abridging of free speech is probably the evilest thing in the past 3 years on planet Earth. Let us know what you think in the comments. If you want to name filaments after living people, follow the hashtag NameThatFilament over on Twitter. And again, make sure you follow us over there, the official account of the Smash News Network, least busted name in news, Twitter at Smashomash, and check it out. Here is the repositioning of this massive plasma filament. So it doesn't look like it's collapsed yet. Part of it is certainly on the way to eject. Let's scroll down a little bit to show even more of that. That is freaking sweet. So this portion right over here is actually looking like it's re-anchoring itself, perhaps. Moving back to the east, that's great, as it'll stay in view for a longer period of time. It's the Eugene Bagashov prominence, folks. Good times. Anyway, let's zoom out here to show the full view, since we've got a huge prominence up there in the northeast also. So that one could actually get a name. That's not the same filament as the Reed Timmer filament. And there's also a couple of crown prominences up there, the northern hemisphere, so plenty of opportunity to name solar filaments after living people. Make sure you do it over on Twitter. Again, follow the hashtag #NameThatFilament. Next, we're doing bonus features. We used to put them in separate videos, but it reduced our views instead of increasing them, so now we do them together with the space and Earth weather. Bonus features starting out with charging hazards, and we have some significant charging hazards here in the central Atlantic. So some significant surface charging there, some large quantities of electrons building on the outside of spacecraft there. That's what the surface charging hazards are. Low energy electrons which build up on the outside of spacecraft. Surface charging hazards. So you could see some minor communications errors from satellite-based communications associated with the Central Pacific. Next, the GOES electron flux. And it did dip as we forecasted. That's the coronal mass ejection impact. As the portion of the ionosphere where that gets measured gets a little scintillated. So that's what's going on with the electron flux over the past 3 days. There is the past year of the greater than 2 mega electron volt electron fluence, or flux. It is measured at the F layer of the ionosphere, and there's the NOAA forecast model. So the next update will be a little bit lower than that green box. That's just the way it works, folks. That's the correlation between the inputs of space weather and the electron flux. Measured at the F layer of the ionosphere. Feel free to pause the video in this frame if you're not familiar with atmospheric temperatures, the penetration of electromagnetic radiation, and atmospheric chemical densities. Here's the layer where it's measured, the F layer. So that is what's shaken at the bridge between Earth and space. One slice of the atmosphere at about 300 kilometers of altitude, the F layer of the ionosphere. And we'll also show the anomalygram. There is the anomaly in megahertz from a 30-day median. And in about 2 days, we're going to expect to see a lot of red on that imagery from a major geomagnetic storm. It does depend on the magnetic field orientation and strength, though, folks. So it could be major, and it could be just moderate. Anyway, here's the latest image. That's 1330 Universal Time ionogram and 1330 Universal Time anomalygram. Pardon the lateness of this video today. We'll also show the electron content. It is literally free electrons. And by the way, a quick side note here. You may have heard of the Russell-McFerrin effect. The Russell-McFerrin effect is the fact that geomagnetic storm conditions happen more frequently around the equinox. It has to do with the angle of attack. So what's happening is the Russell-McFerrin effect is the acceleration of relativistic electrons in the outer Van Allen belt. And this is caused by the angle of attack. So when space weather comes in around the equinox, it's very perpendicular to Earth's magnetic fields, which gives it more of the ability to smash into it. It's basically hitting it harder. Around the equinoxes, it's at more of an angle like this, and that causes a reduction in the Russell-McFerrin effect. less relativistic electrons are accelerated out there in the outer Van Allen belt. Anyway, here's a total electron content forecast. This is the free electrons from ground level to about 12,500 miles of altitude where your GPS satellite orbits. So GPS satellites are only at about half of the altitude of the GOES satellites. The GOES satellites are at like 23,000 miles of altitude. GPS satellites are at about 12,500 miles of altitude. That's literally a count of the free electrons. And we're also going to show the North American total electron content anomaly from the 10-day average. So once again, we are seeing significant high electron content anomalies here over mainly Mexico. You see a lot of red showing up there. Those are those high electron content anomalies. And we're going to close out space weather with the latest sunspots. So here's this new sunspot. First of all, it is beta gamma class. I don't think it's beta gamma delta class. It's just beta gamma class, folks. It has grown somewhat rapidly here over the past few hours. So we'll be keeping an eye on that. When I say ion, well, pardon the pun. Here's this new sunspot in the southeast. There you go. That one is only showing one polarity umbra at the moment, so it is alpha class. Anyway, let's show the full disk rock back. And let's move on to meteorology. So first thing we're going to show is global sea surface temperature anomalies. So this is going to show, that is surface winds are the animation there, that low now over the, whatever that bay is. What is that, the Hudson Bay? I think that's the Hudson Bay. And we've got anomalously warm water there all over the Atlantic Ocean. So some anomalously cold water down here in the western Atlantic. The northern Atlantic there featuring lots of anomalously warm water. I mean, these areas up here, that's over 8 degrees Fahrenheit above normal for this time of year. Not really an indication that the North Atlantic Oscillation is going to be shutting down. If you're hoping for a year without a summer in Europe, it's not happening next year. Just like it didn't happen this year. Anyway, there's the rest of the Atlantic Ocean. Let's zoom out here. We'll show the full planet's surface winds and sea surface temperature anomaly. So there is the Atlantic. Here's the Arctic Ocean. The Indian Ocean is next. Here's the Southern Ocean. And let's don't forget the Pacific, the world's largest body of water and largest surface heat sink. Oceans and the water in them, they have a lot of heat latency. It takes a lot of energy to heat them up, and it costs a lot of energy to cool them down. So that's what's happening. And let's take a look at winds by themselves. There are the surface winds of the east. Here are the jet streams of the east. Jet streams of the central world. Surface winds of the central world. Surface winds of the west. And there are the jet streams. Continuing right along, here's our pressure map from windy.com. And again, you can see that low there making its way up to the northeast. Having broken to bits, we've also got a strong anticyclone here over the north central Pacific. And check it out, this low south of Alaska is actually stronger now than this hurricane remnant. Pressure all the way down to 971, is that hectopascals? Hectopascals. So that is a very strong and huge low there. Check out the size of that low just south of Alaska. Next, clouds and fog over the Americas. A lot of low clouds there over the southeastern Pacific. See all these low clouds massive number of low clouds there over that portion of the Pacific Ocean, a very desolate part of the world. Not a lot of people there to witness those low clouds. There is North America, and here's your weather.gov map. So we do have some smoke showing up from Canada once again, some thick smoke, air quality alerts showing up there around the western Great Lakes states. If your location is lit, click your location. Again, a bunch of storm warnings there around Alaska, as that very powerful and huge low is in charge of their weather. So here's your smoke map. That's firesmoke.ca. Some heavy smoke around California and Oregon there. And also some major smoke there blowing around places like Wisconsin, Minnesota, the central Great Lakes, making it all the way down to Kansas City there, folks. So that's your smoke forecast, courtesy of firesmoke.ca. Shout out to all of you hosers in Canada. And here comes some forecasts. This is the GFS 72-hour pressure and precipitation forecast. Good news for North Carolina. That heavy rain has moved to the east there. So looks like North Carolina is not going to get as much rain as we showed yesterday in the GFS model. And here is the total accumulated precipitation forecast. So that 5-inch rainstorm is now going to be off the coast. So that's good news, as it's not going to cause coastal flooding, at least not as much coastal flooding. 72-hour total accumulated precipitation forecast in inches. Last but not least, here's the temperature anomaly forecast based on the same model, the GFS 72-hour. It is in degrees Celsius, and we've got some very hot temperatures coming to the north central U.S. Montana, the Dakotas, Nebraska, Minnesota. And cold temperatures largely dominating the area east of the Mississippi, the California coast, and the Pacific Northwest. 72-hour GFS temperature anomaly forecast in degrees Celsius. Next, the lightning mapper. That is where the lightning's been striking the past about 10 hours. Here is the real-time lightning map from lightningmaps.org. Highly recommend it next time you hear thunder. Pretend you're a horror movie villain by forecasting thunderclaps. We've got some thunder and lightning there off the coast of Matamoros. So that's what's going on for worldwide lightning. And today's featured product is Universum Liberate. Once again, check out the links in the description. Help this channel remain existent by picking up some merch. Join the Galactic Federation Special Forces, because if you've already brought peace to Earth, it's time to bring peace to the galaxy. So, Universum Liberate. If I could wave my magic wand, I'd set everybody free. If that's too reckless for you, sorry. Convince your friends and foes that you're in the Illuminati by having Latin lingo on your chest, or maybe on your iPad snap case, or maybe on your miniskirt. I don't know, but Universum Liberate. Geddy Lee said if he could wave his magic wand, he'd set everybody free. I kind of agree. I guess I'm just an idealist that way. And if I were able to, I would certainly set your speech free, because abridging people's speech is evil. Links below the video in the description, as well as on our homepage, to the merch shop. So check that out. 37 different designs there. Featured products on the Hemp Lucid shop, which are also linkable below this video, are now, it's on sale. Check it out, folks. Some sales going on. If you haven't tried the Sleep Stacks, Stress Stacks, Full Stack, or Immune Stacks, those are now on sale. Save $15 via our link, again, below this video and on the homepage at smashomash.com. So there are the most popular products, the water-soluble CBD tincture and the CBD caplets. Thanks to our affiliates/sponsors. Save some dough on your products from Hemp Lucid via our link. There's also an Amazon shop there. You can find various products like the coffee that I'm currently drinking. You can even buy the cup that I'm drinking it out of. Check it out. It's my glass coffee mug with Cameron's Scandinavian Organic. When we started drinking organic coffee, guess what happened? We stopped getting the jitters. Yeah. organic coffee. It's highly recommended. Amazon.com/shop/Smashomash. Also linked in the description below this video and on the homepage at smashomash.com. Last but not least, the way to support this channel is by becoming a member of the Smash team. So we launched our own subscription services site in October of 2021. If you want additional content, become a member of the Smash team. If you want email alerts about videos just like this one, become a member of the Smash team. There's a bronze, a silver, and a gold annual paid-up subscription level, as well as a gold monthly membership level. Thanks to the Smash team, these videos are brought to you in part by Smash staff and I at Massive Personal Risk and Expense and the Smash team. So if you're not getting notifications about our video content, just sign up for email alerts. We've provided a solution for that problem. However, we can't make you institute the solution. You've got to do that yourself at smashomash.com/Smash team. We'll close out the video with U.S. Doppler radar, as heavy precipitation shows up around places like Anchorage. And we'll be focusing on the lower 48 to close this thing out, as rain is moving up into the mid-Atlantic states. That's Doppler radar. Here is clouds and fog. That's the infrared satellite at 3.9 micrometer shortwave radiation. And here is the water vapor map. Again, some cold, dry, massive air there coming down from Canada into the northeast. Here's your recap as we bring your space weather and Earth weather together. U.S. Doppler radar. Clouds and fog from the satellite perspective. And there is your water vapor. Hopefully that clears things up. Hopefully you're ready for the geomagnetic storm to show up on the 19th and the 20th. It's time to get this video onto your screen. So thanks for tuning in, folks. Congratulations on realizing the channel exists, and may that solar wind be at your back.